Hello, good day. I'll be sharing my experience and insights about the laboratory experiment number 8 on the PID controller. So in this experiment, we use CISO tool to design and analyze different controllers for a given systems or plant. So I first tested a proportional controller with a compensator, then later compare it with another controller setup that behaves like a PID controller. So during the simulation, I observed that the system responds using a unit step input and analyzed important parameters such as the overshoot, settling time, damping ratio, and peak time. So based on my output, the first controller produced around 30.9%, so overshoot with settling time of 6.81 seconds, while the second controller had a slightly higher overshoot of 32.5%, but a faster settling time of 6.64 seconds. So through this experiment, I understood how changing controllers parameters can directly affect the behavior and performance of a system. So one of the biggest challenges I experienced in this experience was understanding the relationship between the mathematical equations and the actual behavior of the system. At first, it was a little confusing of how adding zeros or adjusting gains in the controllers could change the overshoot and settling time of the response. Like there were also moments where interpreting the root locus and step response graphs became difficult because adjustments in the controller affect the system differently. So another challenges that I encountered was identifying the difference between the PI, PD, or PID controllers and understanding which one is more applicable. So as note to myself, the experiment reminded me that engineering is not always about finding perfect answer immediately. Like sometimes improving one aspect of the system can also create compromises in another aspect, just like how reducing settling time can increase overshoot. And I also realized that PID controllers are very important in real life applications because they help systems become more stable, responsive, and accurate. Like as a future engineer, soon, this experiment taught me the importance of patience, analysis, and continuous testing when designing systems. And overall, this laboratory experiment gave me a better appreciation of control systems and how engineers use them to solve real world problems involving automation and stability. Thank you.